So we are now going to be talking about rate laws. We talk about the impact of concentration of the reactant on the overall rate of reaction. So the general form of a rate law is, and we write this down as rate equals K, which is a constant. And then we can say reactant A to the M power, and then B to the N power. Okay, and then M and N are the order for a given reactant. Okay, we'll talk later on about what order means, but for now, just kind of go with it, and let's figure out how to calculate the order. Okay, so one method we have is called the method of initial rate, which is when you use your understanding of exponent rules, but we're actually going to do another method first, and the method that I prefer that students use, and then you can do them, and then I'll show you how to do the method of initial rate after that. And we'll talk about why we pick one method over another one. So when you look at the Okay, so let's take a look here at the information that's given to you in this graph. You have 3 different experiments ran at multiple concentration of ammonium and nitrite. And then we talk about the initial rate of appearance of nitrogen at these different concentrations. Okay, and as you learned earlier, the way we talk about the reaction rate is that it's defined as moles over liters seconds or molarity per second. So we use this information from the table to help us determine what a appropriate rate law would be for this reaction. So it's very important that we look at the ratios of 2 different experiments, and this is a very important point here that you want to try to pick 2 experiments where only one concentration is changing at a time. Okay, so the very first thing we should do is to write kind of a skeleton rate law, where we say that rate equals K, ammonium, NH4 positive to the M power, and NO2 minus to the N power. And our goal is to determine what M and N are. And then we will also have to determine, I believe you need to determine what the rate constant is for this reaction as well. So the first thing that we need to do is pick 2 experiments. So go ahead and pause the video and look at the data and try to pick 2 experiments where the NH4 plus concentration remains the same while the NO2 minus is changing. So pause the video to look at the data. So you should have picked experiment numbers 1 and 2, and then you notice right here that the concentration of NO2 minus is doubling. And what's happening to the rate of appearance, it is also doubling. Okay, so then to set up the solving for what the exponent is on NO2 minus, okay, keep in mind that it is N right here. We will say here, hopefully you remember this from your pre-calculus class, the 2 to the N power equals 2. And then your understanding of exponents should be such that N equals 1. Okay, and you have to also justify a written explanation of what your work means. And essentially, you're saying that doubling the NO2 minus concentration causes the reaction rate to double. The reaction, therefore, has to be first order with respect to NO2 minus. So once you've got that down, let's go ahead and see if we can determine what the M exponent is for NH4 positive. So once again, we're going to select 2 experiments, but this time you want to keep NO2 negative constant while the NH4 plus is changing. So let's go ahead and select those 2 experiments. So pause the video. And you should have picked experiment 2 and 3. And you can see right here that the NO2 minus is staying constant while the NH4 positive is increasing. Okay, so when you look at the table of data, I'm going to go ahead and change it to blue colored. you can see that as you double the NH4 positive concentration from trial 2 to 3, the reaction rate also doubles. Okay, so once again, the equation is similar to what we had in experiments 1 and 2. 2 to the m equals 2, and m equals 1. Okay. Once again, you need a written justification. So you should say, like we did last time, that doubling the concentration of ammonium causes the reaction rate to double, so reaction is first order with respect to NH4+. So the overall rate law would be rate equals K, NH4 positive, okay, it's implied to be to the first power, NO2 negative. Okay, the overall order of the reaction that the question is asking you for would be 2, because if you add up the exponents, okay, the sum comes out to 2. Okay, the next thing, part C of your question, asks you to determine the value and the units for K. So in this case, you can pick any of the experiments that you've done. So I would go ahead and pick the first experiment here. I'm going to go and highlight that one, these numbers. And we can go ahead and plug in those numbers into the rate law. Okay, so we'll put the 1.35 times 10 to the negative 7 equals K. And then the NH4 plus concentration is 0.1, and the NO2 minus concentration is 0.05. So after you do the math for all that by putting in your calculator, you should get a K value equals 2.7 times 10 to the negative 5. Okay, now notice the question is also asking you for the units of K. And so this one you have to be careful. I'm going to go ahead and address that one point. We can express the rate of appearance as either mole over liter second, but because mole over liter is the same thing as molarity, I'm going to use m over seconds, and let's go ahead and use that one. Okay, so for rate, you would plug in m over s equals K, and then molarity for NH4 positive and molarity for NO2 minus. Okay, this gives you molarity over seconds equals K times m squared. And then I think it's easier just to multiply both sides by the reciprocal on the right side because you have a fraction on the left side. And then when you cancel out the molarities, you get 1 over molarity dot second, or you can say molarity to the negative 1 dot second to the negative 1. And that would be the units for K. Okay, and it's very, very important that when a question asks you specifically for the units, that you write down what the correct units are. Okay. Now, the final part of the question, part D, asks you for what is the initial rate of appearance for water in experiment 1. Okay, and this one, you should not depend on the rate law for this one here or here. Okay, really you're supposed to look at once more your favorite topic, the stoichiometry of the coefficients. So you can see that the ratio from N2 to H2O, we can go ahead and say for 1 and 2, you have 2 H2O. So the rate of appearance for N2 would be 1.35 times 10 to the negative 7th molarity per second. That means H2, you have to double it and give you 2.70 times 10 to the negative 7th molarity per second. Okay, so that can answer fully that question number 1, or that problem number 1 in your notes. So let's go ahead and move further. Okay, so let's go ahead and practice what you just learned for this problem. And here we have 3 different reactions going, so a bit more happening in this case. So once more, let's write our general rate law first. Rate equals K, the rate constant, BrO3 minus, which is the bromate ion, to the M power, Br negative to the N power, and we also have H plus, and then we'll call that to the P power. Okay, so let's go ahead and find out what M is first. So I'm going to go ahead and let you pick the two experiments and compare the rate of reaction. And let's go ahead and pause the video at this point. Okay, so go ahead and check your work, and you should have gotten an exponent of 1 using experiments 1 and 2. And you would say doubling the bromate concentration causes the rate to double, so first order with respect to the bromate ion. All right, now let's try to find out what N is. So go ahead and pause the video while you pick the two trials and work out the math. So once again, if you did this correctly, you would have gotten an exponent of 1. So doubling the bromide concentration causes the rate to double. So it's going to be first order with respect to bromide. All right, and then finally, let's go ahead and find out what P is. So once more, stop the video and do your thing. So if you did this correctly, you would have used experiments 1 and 4 because that's the one where the concentration of H plus changes while everything else is constant. And you notice in this one that doubling the concentration actually causes the reaction rate to quadruple. So by using the exponent rules here, you'll notice that P is 2. And the written explanation would be doubling H plus causes the rate to quadruple. So it's second order with respect to H plus to give you this overall rate law. Okay. So now let's go ahead and pick trial 1 and go ahead and pause the video now and to plug in these values in to find out what K is and also take the time to figure out the units. So go ahead and pause the video right now. Okay, and go ahead and check your work, and you should have gotten a value of K of 8 for K. And it doesn't matter whether you use experiments 1, 2, or 3, or 4, you would have gotten the same number regardless. And the unit, you can see my work here for K, would have been either this one, 1 over m cubed times S, or molarity to the negative cube times second to the negative 1. Okay, so that's how you use the table method to figure out what a rate law is from the data. Okay, so now moving on. If you look here, let's talk about what this ordered business means. Okay, and what you want to look at here is this, look at the concept. So this one here would be first order. This one would be second. And then this one would be third. Okay, going over third order is extremely rare, so we're really only concerned with mostly first and second order, maybe a teeny tiny bit with third order. So if A doubled, okay, what you can do here is you can go 2 to the first power, which is 2, so you would say the rate would double. Okay, if it was second order, 2 to the second equals 4, so rate would quadruple. Okay. So then by the same token, 2 to the third equals 8, not 6. The rate would increase by a factor of 8. So what does order mean? It is about the magnitude of the rate of reaction increase when the concentration of either one of the reactions increases. Okay, so that's how we define what order is. Okay, also keep in mind that you can have zero order, which means that increasing the rate of reaction, increasing the reactant concentration will have no impact on the increase in the reaction rate. Okay, like the overall magnitude of it. Okay, so let's make sure we study that a bit more, and hopefully it'll make sense as you're doing the kinetics program. Now, the advantages of the second method is that you don't have to write written explanation as to how you arrived at what the order is, and you can let the calculations speak for themselves. So once more, we come up with a general form of rate equals K NH4 positive to the m power, NO2 negative to the n power. Okay, and once more we put experiment 2 and experiment 1, but this time we made it like this: experiment 2 divided by experiment 1. Okay, and then you're going to put the rate of experiment 2 on top, 2.7 times 10 to the negative 7 over 1.35 times 10 to the negative 7 equals K. And then the NH4 plus concentration experiment 2 is 0.100 to the m power and 0.010 to the n power for the NO2 minus. And on the bottom, we put 0.100 to the m, 0.005 to the n power. And then using your understanding of exponents and division, these cancel and these cancel because they're the same. So when you simplify that expression, you get 2 equals 2 to the n power, and n equals 1. Okay, and then we can do the same thing for experiment 3 over experiment 2 to figure out what the m is. Okay, so we can say 5.4 times 10 to the negative 7th over 2.7 times 10 to the negative 7th equals K. And like this, and then you can see there's quite a bit of writing involved in this one. And then you can see this time this is 2 equals, the k's will cancel out, and this time this part will cancel, leaving you with 2 equals 2 to the m power, m equals 1. Now, the nice thing about this method is you don't have to write down what we did earlier about how doubling one concentration will cause the other, the reaction rate to double, etc. But the reason I don't always like this method is because it could be a little bit time consuming to write everything out in terms of the number, and also because I think it's really important that you understand what the order is. Okay, so that's it for this lecture. So have fun. Bye-bye.